Okay, hi guys. So let's continue with the second part of substitution method. Okay, we move to example 3. Okay, evaluate the following indefinite integrals by using the substitution method. Okay, so if you see from A, B, C, D, and E, so we have a more complicated function. Okay, compared to the previous example we have discussed. Previous example we have discussed only for exponent, okay, trigo, sine x, sine 5x, okay. So this one is more complicated function. So and we will use the substitution method to solve the integral. Okay, let's begin with A. Okay, we have the integral A. Okay, the function that you need to integrate is 2x plus 3 over x squared plus 3x plus 2. Alright, so this is substitution method where you need to substitute or you need to let u with one function. Okay, we have a fraction here, okay, where we have at the top is 2x plus 3. Okay, we have 2x plus 3. Okay, and as the denominator is x squared plus 3x plus 2. So we need to choose either we want to have u equal to 2x plus 3 or u equal to x squared plus 3x plus 2. Okay, so the idea for substitution method is after you let u with some function, so you need to differentiate that function. Okay, and so that if you differentiate the function, so you can use that to modify the original function. Alright, so from these two choices, if you differentiate 2x plus 3, so you get 2, right? Okay, so if you get 2, so you actually you cannot use that 2, okay, to continue or to proceed with the integration. Okay, but if we differentiate the second function, which is u equal to x squared plus 3x plus 2, so you will get 2x. So that 2x is actually can be used to cancel out the 2x plus 3 at the top. Okay, so the idea is if you have this polynomial, okay, two polynomials, so one idea is to use or to substitute u with the function with more order of integration. Okay, the higher order integration compared to the other function, right? Okay, so this one, okay, now we let u equal to x squared plus 3x plus 2. Okay, so second step is to find du dx. So you get 2x plus 3. Okay, and then rearrange, so we have dx equal to du over 2x plus 3. Okay, so what's next? So what you need to do is to restructure the integration. Okay, we have the same integrand here. Okay, 2x plus 3 we just maintain as 2x plus 3 at first. Okay, and then this x squared plus 3x plus 2 we have replaced with u, so we put just u here. Okay, and then the x we have changed to du over 2x plus 3. Okay, so we have du over 2x plus 3. Okay, and if you look at the function, okay, the integral, the function in the integral, so we have u and x variable, right? Okay, but this 2x plus 3, k can be cancelled out. Okay, and so we will just have 1 over u du. Okay, so if you have 1 over u du, so you can have the integration, the output will be ln u plus c. Okay, but you cannot just put ln u, you need to substitute back that u equal to x squared plus 3x plus 2, and then plus the constant. Okay, so this is the answer for A. Okay, let's move to question B. Okay, the function that we need to integrate is x over x squared plus x squared minus 4. Again, this is a fraction. Okay, where we have the first function is x and second function is x squared minus 4. So we will let u equal to x squared minus 4. Okay, do you understand why we choose u as x squared minus 4? Okay, because we have just now x and x squared minus 4, so we choose the polynomial with higher order polynomial. Okay, so we can have later du dx is equal to 2x, and rearrange dx as du over 2x, du over 2x. Okay, and now the integrals will become x over u dx is du over 2x. Okay, again here you can cancel out the x here. Okay, so you will have only 1 over 2, I just bring it to the front, 1 over u du. Okay, again if you have 1 over u, integrate 1 over u, you will get ln u. Okay, and that u you need to replace back by x squared minus 4. Okay, alright, so this is the answer for question B. Okay, let's move to question C. Okay, so for question C, okay, we have 12x squared plus 16 over x cubed plus 4x as the function that we need to integrate. Okay, again this is a fraction. Okay, if you have if you see the functions, okay, we will have the numerator, the order is 2, okay, x squared, and the denominator is x cubed, so the order is 3. So we will choose u as x cubed plus 4x. Okay, and from here differentiate it, and you will get 3x squared plus 4. And from here we will have dx equal to du over 3x squared plus 4. Okay, so we have all the substitution, okay, u and du dx. So we substitute all the functions into the to the original equation. Okay, 12x squared plus 16, we will just maintain it as that. Okay, x cubed plus 4x, we have replaced with u just now. Okay, and dx will be replaced by du over 3x squared plus 4. Okay, now if you see, okay, we have in terms of x and u. So from here, you have this one is 3x squared and this one is 12x squared plus 16, which are not equal. Okay, but you can modify that. Okay, how are you going to modify? Okay, you can factorize, okay, this 12x squared plus 16. Okay, you can have it as, okay, I just bring 4 in front, so so I will have 4 times 3x squared plus 4. Okay, if I expand this, so I will get 12x squared plus 16 over u. Okay, and we have the same terms here, which is du over 3x squared plus 4. Okay, so now we can cancel out that. Okay, so we have 3x squared plus 4 and this 3x squared plus 4. So you will have later, okay, I bring 4 in front, so we'll only have integration of 1 over u du. So this one again, so you get 4 ln u plus c, and that u you substitute back with x cubed plus 4x plus c. Okay, so this is the answer for question C. Okay, so let's continue with example D. Okay, so example D, combine polynomial and also trigonometric. Okay, again for this question you cannot integrate directly. So since we are in topic of substitution method, so the best solution is to use the substitution method. Okay, so we have how to choose u. Okay, so we have two functions there. Okay, one with x plus cos x, and another one is 3x squared plus 6x. So just refer to the here 3x squared and x. So the highest is 3x squared. Okay, so we will choose u as 3x squared plus 6 sine x. Okay, and same as before, so differentiate u with respect to x, so you will get 6x plus 6 cos x. Okay, and now we will substitute this one. Okay, x plus cos x will maintain, so 3x squared plus 6 sine x we have left as u. Okay, sorry, so this one I haven't write the du right, sorry, dx. So dx is equal to du over 6x plus 6 cos x. Okay, so here we return back here, so this one will be du over, so if you see here, these two are the same, which is 6, so I can factorize that 6, so just x plus cos x. Okay, so we can cancel out these terms, all these terms, right? And we only have 1 over 6 in front, 1 over u du, so we will have 1 over u ln u plus c. Okay, so we change u as 3x squared plus 6 sine x plus c. Okay, so this is the answer for D. Okay, so we will continue with the last example for substitution method. Okay, so we have the last question is we have the function x over square root of 1 plus x squared. Okay, so how to solve this? Okay, we have square root there, right? So actually you can actually it's just the same as what we have discussed before. Okay, if you want to use the substitution method, you need to let u. Alright, and okay, we let u as one function. You can choose either x or other functions. Alright, if you choose u equal to the whole function here, 1 plus x squared. Okay, so this one you can write as 1 plus x squared to the power of half. And if you want to find du dx, so you need to use, do you remember how to differentiate this? You need to apply the derivative of powers of functions. Okay, so become 1 over 2, 1 plus x squared. This one will become negative 1 over 2, and you need to differentiate in the bracket. Okay, and you have this function. Okay, if you choose all the including the square root here, okay, the function will be more complicated. Okay, if you still remember the previous example, we consider the polynomial, okay, where we will let u as a we will let u for the function with polynomial with more order. Okay, the order of the polynomial is more than the other one. Okay, so same as this one. So you don't have to put everything, okay, the denominator as the u, okay, but we just select the polynomial, which is 1 plus x squared, so that if you differentiate u with respect to x, you only have 2x, and this 2x can be cancelled out with the x here. Okay, so the same step. So we have dx equal to du over 2x. Okay, and now okay, we will have x over, okay, so this one will be different. Okay, you not only put as u, but we have the square root of u at first. Okay, because we have substitute u equal to 1 plus x squared, not the square root. Okay, so we'll have x over square root of u dx. So dx is du over 2x. Okay, so this x can be cancelled out. Okay, and we will rewrite as 1 over 2. So square root 1 over square root of u is what? U to the power of negative half. Okay, still remember, don't just put as 1 over u and then find the integration, you get ln. Okay, no. Okay, so this is square root of u, 1 over square root of u, so you change it to u to the power of negative half du. Okay, so solve the integration. Okay, so this one you cannot get ln. Okay, you just use the basic properties of integration, where you will get what? U to the power of half, because you have negative 1 over 2 plus 1, so you get half over 1 over 2. Okay, plus c. So this one can be cancelled out. So the answer is just u to the power of half. So again, we just substitute back to 1 plus x squared. Or we can write as square root of 1 plus x squared plus c. Okay? Right? Any question? Right, I just recap one basic properties of integration. Okay, if you have x to the power of 4, for example, integrate, so you get what? So you get x to the power of 5 over 5 plus c. So this is what I did for this one. Okay, alright. Okay, so that's all for substitution method. Okay, so we'll meet again later. Alright, thank you, bye.